Hi, hello everyone. I'm Dr. Prasad. Uh, Continuing my class series on biology for engineers. Okay, so I am on module 5 now, starting of module 5. This is subject code 21BE 45, common to all fourth year, fourth semester branches of VTU Karnataka. Okay, the videos are available in my YouTube channel, My Intuition. Notes are available at payment basis to WhatsApp number 797-505-4865. Each module I am charging 10 rupee each, or I can collect all the 5 modules with 40 rupees. Okay, so that is the payment mode, and I'll communicate you when you put a message to my WhatsApp number 797-505-4865. Okay, it is the, you can see that, you can note it down. Okay, so module 5, the syllabus, it is given like this. It consists of bioprinting techniques and materials, 3D printing of ear, bone and skin, 3D printed food, electrical tongue and electrical nose in food science, DNA origami and biocomputing, bioimaging and artificial intelligence for disease diagnosis, self-healing bioconcrete based on bacillus spores, calcium lactate nutrients and biomineralization process, and bioremediation and biomining via microbial surface absorption, that is removal of heavy metals like lead, cadmium, mercury, arsenic in short. Okay, so that is the syllabus. I am prepared a single note for that, but I will be covering point wise only. I will be covering. Okay, so for first point on this topic, that is bioprinting technique and materials. Okay, so bioprinting technique, it is similar to that of the 3D printing, but only the thing that here we are using the printing ink as the biomaterial, or we are using uh, the required biology, the required cells, living cells, as the ink for the growth, for the production of a 3D design. Okay, so bioprinting is rapidly growing field that uses various techniques to produce three-dimensional structure and functional biological tissues for biomedical, for medical and scientific applications. The main objective of bioprinting is to mimic the structure and function of human tissue and organs, leading to the development of or replacement for damaged or diseased organs. Okay, so the procedure is given here. A, start from A. Okay, so if you want to identify a place or a region of our body which has to be replaced, then 3D scanning happens and it will give the design or shape of that which is needed to be replaced. Then the required bio ink is synthesized. Then the 3D pin bioprinting process, it happens, it gives that shape, then it allowed to mature, to, because it is a living thing, so it should become ready for application in our body. Even the blood stream also should be made available through that, so that it will be become a normal tissue type, then it is applicable, it is replaced with that. Okay, so this is the representation of that 3D bioprinting process. Okay, so an example is given here. If you want to replace a person's heart, okay, every person's heart is not they are almost unique. Okay, therefore we have to get a 3D printing of that one and get it printed, 3D printed by using the bio ink. Okay, now the comparison between the 3D printer, normal 3D printer that we use to get different objects, intricate objects we prepare by using 3D printing. 3D printing is three-dimensional printing. Normal printing that we get in our paper, that normal printing, whether it is color or black and white, that is two-dimensional printing, X, Y direction only. 3D printing means it goes the Z direction, three-dimension printing takes place. That's why it is called as a 3D printing. Okay, here also you can see, and only on this plate means that is two dimension, and it is going above that plate, that is the third direction, or the Z plane. Okay, so bioprinters as well as normal 3D printers are having the same work, that is 3D printing only, but the comparison based on the biology concept, that comparison is given here. Printing purpose, the 3D printer, it is a general purpose printing of objects. whereas bioprinters, it is to replace the living, it is a fabrication of living tissues and organs. Material used in 3D printing is plastic, metal, ceramic, etc. Whereas in bioprinter, it is hydrogels, extracellular matrices, cell aggregates, etc. So we'll see. I'll show you what are extracellular matrices, what is cell aggregates in the coming classes. Okay, application, manufacturing, engineering, product design, architecture. In all these cases, the 3D printed materials are used. Whereas the bioprinter, 3D bioprinting, it uses regenerative medicine, tissue engineering, drug development, etc. Printing process, it is an additive manufacturing, layer by layer deposition, that is one after the layer, three dimensional, okay, x, y as well as z direction, one after the other, layer by layer, the deposition takes place. Here also it is a precise deposition of layer by layer, but using bio ink. Cell compatibility, if you take that topic of cell compatibility, 3D printer has nothing to do with cell compatibility, therefore it is not applicable. I mentioned Na. Whereas here in bioprinters, bioink must support cell viability and function. Okay, it should have a compatibility. The ink that is used, the ink which is used for the printing, it should be compatible with the human body, otherwise it will create a irritative action and body will resist to that. It creates so many issues. Challenges, right now compared to the biology concept, 3D printers having not applicable actually. Okay, therefore it is Na. There's no application. It is not applicable towards this term. Whereas in bioprinter, we have to develop a suitable bio ink. We have to check about the cell viability as vascularization as well as scaling up. Cell viability and vascularization I put as a note. Cell viability, it refers to the ability of cells to remain alive and maintain their normal cellular function. That is called cell viability. Whereas vascularization, it refers to the process of creating the functional blood vessel networks within bioprinted tissues or organs. Then comes the advantages. 3D printers are versatile, wide range of application, enables rapid prototyping, cost effective. Whereas 3D bioprinter, their potential for tissue and organ transplantation, enables the tissue engineering and regenerative medicine. It can create tissue models for study diseases, potential for personalized medicine and drug testing. Okay, no complicated. Limitations, limited ability to create functional, compared to the bio concept only, the this one is prepared. Okay, compared to bio, 3D printers has limited ability to create a functional living tissues. 3D printer cannot prepare, very limited ability. Yeah, okay, limited choices of material for certain application, lack of cell compatibility and tissue functioning, because the ink used or the material used, they are not at all compatible with our body. Whereas in bioprinting, limitation, complex and rapid evolving technology, challenges in developing suitable bioinks and scaling up vascularization and long-term functionality of a printed tissue. These are the present limitations of the 3D bioprinter. Now the material which are used, bioprinting material, which are the inks which are equal as the ink material which is used. Okay, it should be compatible with our living cell. It should support the environment for their growth and organization. So some of the example of bioprint material which is already started using are hydrogels. Hydrogels are actually, hydro means water, gel means gel type. No, that polymer actually it is. Actually, hydrogel, it is a polymer. It is a polymeric network which will absorb almost 100 times the normal weight of that polymer. Such a polymers we call as hydrogels. Okay, normally we call hydrogels. Hydro means what? Okay, it absorbs maximum up to 100 times its normal weight if it absorbs the water. Such a material we call as hydrogels. Once it is absorbed, that state it is showing. Okay, which this one closely mimic the extracellular matrix. You see, extracellular matrix means it is the our body's tissue supporting system. Okay, I'll explain in later in coming classes. I have image and all for that. Okay, so right now just imagine that it is almost similar to our body, that structure material. normal structure material will hold the cells together. They offer excellent biocompatibility, mechanical support is good. It can be formulated to have similar physical properties to the native tissues. Compared to our normal tissues, these hydrogels can be formulated accordingly. Okay, so examples also given, like gelatin based hydrogel, alginate, fibrin based hydrogel, collagen based hydrogels. Next one, that is cell laden aggregates. In some cases, the cells are first aggregated into a biomolecule and a biomaterial or with the micro tissues before being incorporated into the bioink. Either it is mixed with a biomolecule which is synthesized, synthetic biomolecule, or even normal biomolecule, naturally available biomolecule. The cells are first aggregated, it is mixed and made as a composite type, not composite as such. They are aggregated together to form a bioink. This aggregate will provide more physical environment. Okay, so such one example is given. How, what is that aggregate? Okay, the cells with along with the biomolecules and biomaterials, they are mixed together to form a this particular shape which is called as a cell aggregate. Okay, this type of shape which is called as cell aggregates. So such cell aggregates cell aggregates are prepared mixed with the along with the bioink, so that it gives more support to that system. Or we have decellularized extracellular matrix. Okay, so now extracellular matrix I will tell from the beginning only until that I will explain. Okay, so it is given here. Okay, with the compared to the epithelium, endothelium, and connective tissues are presented here. So this whole structure I can say that is extracellular matrix. Okay, so it consists of membranes, it consists of even small cells, it consists of the connecting tissues. All those things are available in that. So is that extracellular matrix, so it is a complex network of molecules surrounding cells in tissues and organs, which provide the structural support, biochemical signaling, and regulatory functions. Okay, so the ECM of tissues can be extracted and processed to remove cellular components, resulting in a decellularized extracellular matrix. The problem is, from this extracellular matrix, if the things are removed, when the soft tissue, if it is removed, that cellular part, if it is removed, the remaining portion we can call it as decellularized. D means removed. Okay, so cellular part is removed, it becomes decellularized one. Okay, so that also used in bioink application. Okay, some example is also given: porcine small intestines, submucosa, decellularized porcine or bovine dermis, decellularized amniotic membrane. Okay, very difficult to pronounce the name itself. Now, synthetic based bioinks. Synthetic polymers can be used to create bioinks with well defined mechanical properties and degradation rates. Okay, so these bioinks provide control over various parameters such as stiffness, porosity, and degradation. Means polymers also used as such, not only hydrogels, other polymers which are not hydrogels, like polyethylene glycol, PEG, polycaprolactone, or polylactic glycolic acid based bioinks are also used. Or even we can use the composites. Composites are a mixture of two or more materials, so that it will give mechanical strength, printability, cell behavior. All these are included. What is examples? Okay, so examples include gelatin metacolloid, collagen combined with hyaluronic acid, fibrin combined with nanoparticles or growth factors. Now, some of the most commonly used bioprinting techniques. After that, I will stop this video. That remaining I will continue in next video. So, most commonly used bioprinting techniques. Okay, I'm not going in detail. Technique already you might have studied. Inkjet based bioprinting. Inkjet based bioprinting means the material, the bioink is taken, and by using a small nozzle, the ink, a jet of ink, it is applied on a substrate. We call it as inkjet bioprinting. Extrusion based bioprinting. Extrusion based means this particular shape with a long cylinder and a very small nozzle, we call that cylinder that shape as a extrusion portion. So if the ink is taken inside that one, and if it is allowed to free flow, gravitational force, it become pneumatic extrusion based bioprinting. If you are using a piston just pushing, then it is a piston based extrusion, or even you can use the screw type, rotating screw type, so that when it rotates, it pushes, it has to pass through that screw, that passage. So again it pushes only, though that it is simply rotating, but material is pushed inside. That is extrusion based bioprinting. Material is bio ink is used. Laser assisted bioprinting. In laser assisted bioprinting, the bio ink, it is taken above that a ribbon is connected, a laser beam which is focused to on the surface where the ink has to act. Wherever the laser beam is fallen, there it becomes a bubble then convert into a jet, then it started depositing on the substrate. As the laser moves, the jet also move accordingly. That is laser based bioprinting. Or micro valve based bioprinting, we are using a micro valve. Micro valves are used, pulse generators are used. Based on the pulse generator, the current, the pulse which is generated, the micro valves will open and the printing takes place. With the solid freedom fabrication, normal 3D printing cases the same type. I took the that example only. So this is a fusion fused deposition modeling. The material which has to be printed, it is taken in a solid form. Supporting material also taken in solid form, and it is taken inside a nozzle, and it is heated so that it becomes fused. Okay, then it has applied on that x y z direction to get the printing. That is one of the SFF method, that is fused deposition modeling. Or we can use a stereolithography. Stereolithography, only the concept I presenting here with image. Okay, so yeah, using the platform, on the platform, a cured resin part, a resin, solid resin, solid part of resin is kept, which is kept inside a liquid resin, to which the laser beam is passed, and we are just drilling it, scratching it out, etching it out, or we are writing on that. Writing means removing actually, not depositing. Okay, so that method, lithography means actually writing. Okay, so this particular method is known as a stereo lithography. Okay, so you can see that shape is formed. Actually it was a square, perfect square, this yellow region, it was perfect square. On that the lithography is done, and it made into a required shape. That about printing, different printing methods. Now the basic steps of bioprinting: preparation of the bio ink, design of the tissue structure, printing, incubation, assessment. Okay, now much complicated sentences are there, only made it as a sentence. Okay, so I made it as a flow chart. So this is the process. Okay, so the field of bioprinting is constantly evolving, and new techniques and materials are being developed to improve the accuracy and reliability of bioprinted tissues and organs. So this much is for the first class of this module 5. Okay, then 3D printed ear, 3D printed bones, skin, all those are ready, but the later part are yet to be prepared. So I'm stopping the class here. Okay, so if you have any doubts, you can ask me over my WhatsApp number. Over my WhatsApp number, you can ask. If you want the study material, module 1, 2, 3, and module 4, four modules completed. Fifth module, this one is getting ready. Okay, so those who are wanted to purchase it, you can purchase it from me. Contact me on WhatsApp number 797-505-4865. So thank you very much for subscribing my YouTube channel, view my videos, and supporting me by sharing this information. Thank you very much.